Okay, here we go. Section 4.2, removing common factors. So we're going to review a little bit here. If you're using, you should remember how to do prime factorization using the factor tree. And there's two real methods to find the greatest common factor. So remember, greatest common factor is just the biggest number that goes into whatever what you're looking at. So here we have two numbers here. So to find the greatest factor, what's the biggest number that goes into 35 and also goes into 84? Okay. So this one's pretty simple. So you can also include itself, right? So the great GCF here would just be 16 itself, since 16 is obviously the biggest number that goes into 16, and it goes into 32 as well. Okay. But what if we had bigger numbers or something that's not as obvious? So what would be the GCF here? The first method is to list them out. So if you just go 35, you can list them, 1, 3, 5, etc. Keep going down the list. 7. But another way to do it is to use a factor tree. So what two numbers multiply to 35, not including 1 in itself? You can say 5 and 7, right? And then you do the same thing, two numbers that multiply into the 84. You got 7 and 12, for example. Okay. Um, yeah, then we could break down the 12 further down into 4 and 3, and then finally we can, let me just make a line here. We can break down the 4 into 2 and 2, right? So now you circle whatever the common prime numbers are, and then if there's more than one, you multiply them together. So here, there's a 7 here, and a 7 there, and then this one has 2, 2, 3, and then 35 has a 5, but they're not in common. So the GCF here is just going to be that 7. Okay. So that's another method to do it. So we'll look at that method a few more times. So I'd break down the 45 using the factor tree. So 45, 5 times 9. 5 is a prime number, but the 9 we could break down to 3 and 3. Okay, now let's break down the 75. So 75 we break down 5 times 15. 5 is a prime number, but let's break down the 15 to 5 and 3. So what do they have in common? We'll only look at the prime numbers. It says 5, 5, and 3. This says 5, 3, 3. So they both have a 5 and a 3. So once you do that, you can multiply those two together. 5 times 3 is 15, all right? So that's that method. You could have also obviously just done 45 and then start listing them, right? So what multiplies into 45? There's, 1, 3, 5, um, uh, probably gonna miss some, so 15, 9, and 45, right? And then you could just listed 75 as well. So, there's, what is there? 1, 3, 5, uh, that's no, 7, 8, nope, 9, nope, 10, 15, 25, 25, and is that it? Okay. But anyways, then you'd go to the biggest number here. So we got our 15 here and our 15 here. So that's the biggest number that they have in common. So you could have done it this way, or you could have done it this way. So going forward, I'm just going to do the tree method, the prime factorization, because that's kind of what we've been talking about in this course so far, or in the last unit. So here, let's just do these quickly. Now we have the variable x as well. Okay, so just break down the number first, right, into its prime roots. So we got 3 and 7. This can break down into prime roots 3 and 6, and then 6 can break down into 2 and 3. So what do they have in common? They both have 1, 3, right? So you know that 3 is the GCF, but you also have to look at the variable. This has an x, this has an x squared, so they both have at least an x, right? So there we go. Okay, so let's do this again. 10, 3, 5, 2. Okay, let's break this one down. So we got 10, 7, 5, 2. Okay, there we go. So they both have 5 and 2. So you can multiply 5 times 2. We could have actually stopped this. Probably didn't even need to break it down, but it's okay. So 5 times 2, we got our 10. So we know 10 is the biggest coefficient. Now we have to look at the variables. So in here, this has 2 m's, so m squared, and it's 2 n's. This has 2 n's and 1 m. So they both have at least 1 m, and they both have 2 n's, so n squared. There we go. Okay. And the last example here, same sort of thing. So break this down to 8 times 3. You know, I could break the 8 down further, but I can also just go to the 64 and notice that it goes to 8 and 8. So whatever 8 breaks down into, it's going to be the same thing here. So they both have the 8. So kind of skipped a step. So 8, and now we just have to look at the variables. They both have an A, they both have a B. So A, B. We can't write C because C is here in the second term, but not in the first one. Okay. All right, so that should be somewhat a review. So let's look at, I guess, a new section, a new bit, part of it. A factor by removing the greatest common factor. So here what we're doing is we're trying to get in from this form into the factored form. Okay, so how we do this is we think of the GCF. So once you do a few of these questions, you can start doing them in your head a bit, for the GCF part at least. So what's the biggest number that goes into 3a and 15? So you know it's just going to be a coefficient because this one doesn't have a variable attached to it. So 3 goes into 3a and it goes into 15. And then, so if we pull the 3 out, right, because both sides, so 3. So 3 times what gives you 3a? 3 times a, right? 3 times a gives you 3a. So we're basically dividing both terms, and then 15 divided by 3 gives you 5, just like that. So, and if you want to go backwards, you can like FOIL it out kind of thing. So you go 3 times a is 3a, 3 times 5 is 15. So this is the factored form. Okay, so let's do a few more of these. 21 and 14, the biggest number I can think of is 7, and then both have, this is an m, this is 2m, so they both have at least 1 m, so you can divide both by 7m, and then whatever you're dividing it by goes outside the brackets, so 21m squared divided by 7m, 3m, and negative 14m divided by 7m, m's cross out, right, so 14 divided by 7 is 2. Okay, let's look at this one. Here, what's the biggest number that goes into both? I can see 9, and both have b squared, or 2 b's in them. And then we can get 9b squared. And this is 9, 18, 27, 3b plus 5. Yeah, that's about it. Okay, there we go. Okay, so a few more examples. The practice I'm not going to do because this is exactly the same thing what I'm doing up here. But I'll post the answers of the practice questions in the class notebook, and you can do these in addition to the textbook stuff if you like. Okay, so here, same sort of thing. What's the number that goes into all three? And I see the biggest GCF is 5, and you can't use m because the third term doesn't have an m. So 5 m divided by that is, oops, that's wrong, 5 m cubed plus 2m squared plus 5. Okay. Okay, I'm running out of room for this one, but I'm pretty sure it's very similar. Let's do the last one here. So what's the biggest number that goes into 6x squared and y? 6x squared y and the other two terms. I can see 2. Seems like the biggest one. And do they have any variable common? Yeah, they all have an x, right? So we're basically dividing everything by 2x here. So 2x, that's going to be 3xy plus 2y and minus 4. Okay, good. There we go. Okay, so hopefully that is pretty straightforward. Practice questions you can try on your own time. But we should probably go over this section here. So for this section, again, I'll go over the examples, and then the practice, which is exactly what's going up here. You can try this on your own time, and again, the answers will be on your class notebook. So here it says factor by removing the common factor. So the thing here is the trick is binomials can be a common factor as well. So what does this term and this term have in common? They both have this x plus 5, right? So we can write that down. And then what do we put as the second binomial here? We're going to put down whatever's on the outside here. So x and 7, x plus 7. So that's all you really need to know. So if you FOIL this out and you FOIL this out, it's going to be the exact same thing. So that's how you do that. So let's try this again. So x plus 3, both common factors. You can take that out. And then the terms on the outside, you can put in a separate bracket. So x, negative y. And lastly, we have b minus 1 obviously is a common factor here. So take b minus 1 out. And the outside factors, or the outside numbers here, and then plus 2 over here. Okay, that's it. Last little bit at the bottom here. So factor by grouping. Okay, so what we could do here is we can group, we see questions like this, you can kind of group things that are in common. So we can see that these are very similar and these two are very similar. They both have, just by looking at it, both have 5s, and this one both has 2. So if we factor this out, what do they have in common? They both have 2 and they both have a squared. And then 2a squared times what gives you 2a cubed. You just need to multiply by a, and then 2a squared times y gives you 2a squared, just 1, right? It's the same thing as saying, like, I'm just dividing this by 2a squared and this by 2a squared and putting those numbers down here. Okay, so the second part here, we got they both have 5, so I can just simply put plus 5. So 5 times y gives you 5a. A 5 times y gives you 5, just plus 1. Okay, there we go. What else could we do now? So now from this step, it looks like, the form like this. So we have one more step to do here. So once you get to this point, after factor by grouping, you can see that they have the same, binomial as in the brackets. So you can simply go a plus 1 from the binomial, and the other bracket would be, hopefully you guessed this, the 2a squared plus 5. Okay, so we'll try that a couple more times. Okay, so here, factor by grouping, right? So we can see that they both have an m here. M times what? Times m plus n gives you the first section. And the second group here is they both have a negative 6. So negative 6 times m plus n, right? So negative 6 times n gives you negative 6n. And now the second step, you put the binomials are the same, so you put them together, m plus n, and the outside puts m minus 6. Right, the m from here, and this is negative 6 from here. Okay, last example here, factor by grouping. So you group these two together, because you can see that 5 is in common, and this just looks pretty straightforward. This is 12 in common. So you can take the 5 out, and they both have an x squared, so you can take at least an x squared, this is x cubed. So 5x squared times x gives you 5x cubed plus 2. So 2 times 5x squared gives you 10x squared. And the other side, they both have a negative 12. This has an x, and this we'll need to multiply it by 2 to get negative 24. Negative 12 times 2. Okay, now again, just collect the brackets together. So on one side we got the binomial, which is the same, x plus 2. On the other side we got the 5x squared and the negative 12. And that's it. Okay, so this is confusing. You can take a look at it, obviously, a little bit longer. You can try the practice questions, see if you can get the right answer. Try the textbook questions, and obviously ask me for help. Okay, I'll see you guys in section 4.3 next.